Hello, everyone. Welcome to our latest DZone webinar. My name is Jason Cockrum. I'm the community manager here at DZone, and we're glad you're here today. We've got a pretty exciting topic, and so we're happy that you've joined us. If you're new to DZone, we are one of the world's largest online communities of software developers and experts, and we publish all sorts of knowledge resources for developers and really anyone passionate about software development. We've got all kinds of stuff like ref cards and trend reports and thousands of articles written and published by our community. And all this makes us kind of the go-to knowledge hub for developers all over the world. We also have a ton of great events, just like this one, and you can find them all at dzone.com/events. So I encourage you to head over there. You can see all the past events that we've done. You can see our schedule for upcoming events that we've got, and there's a lot of really great topics there. So go check that out for sure. Joining me today is Justin Fine. He's the Director of Field Engineering for Katana Graph. He joined Katana Graph in September of 2021, bringing years of experience in big data gained from some time at a few little known companies like Microsoft and Accenture and Neo4j and a few others. And his background in applied math includes a lot of graph and matrix algebra for solving graph-like problems, making me really wish he'd been around when I was in high school. He later worked with a lot of anti-money laundering and fraud analysis for governments, banking institutions, telecommunications, and things of that nature. So as you can see, he's got a pretty wide range of experience, and it sounds like he might have some pretty interesting money laundering stories he might have to tell someday. Now, about the webinar, today we're going to be talking a little bit about how artificial intelligence, and it's one of the biggest topics in development right now, and companies all over the world are leveraging the power of AI to build better products and grow their business. But AI requires vast amounts of data to be able to generate the results that we need and the results that we want. And a lot of companies struggle with connecting those large data pipelines together efficiently across their AI pipeline. So Justin's going to walk us through how the Katana Graph Intelligence Platform uses graph algorithms to enhance AI pipelines and deliver the results that we need. Data always tells a story, right? And using these algorithms effectively can make sure that our data is telling us the right stories that we need to know to make better business decisions. So Justin's going to talk for just a few minutes about all that stuff, and then I'm going to come back on towards the end and wrap us up. So Justin, go ahead and take it away.
Absolutely. Thank you, Jason. So I had the opportunity, as was mentioned, to work in a bunch of different areas, but one thing that I found that connected us all together, which is funny, is graphs, right? So a lot of these very complicated problems start with a lot of data, and they wind up having the same basic series of events that you have to go through in order to solve problems. So right now, today, I'm going to talk a little bit about Katana Graph at a very high level, what the intelligence platform does. Then I'm going to get more into a specific use case around fraudulent actor analysis, fraud in financial services, if that's okay with everybody. That being said, let's talk a little bit about Katana Graph. So one of the reasons I joined Katana is because there were some very difficult problems that were not being solved in some of the other companies that I've been in. When you start getting these very large data problems, you have issues with speed. So you optimize for speed, but then you can't ingest the data you need. So it's either one or the other in a lot of these cases. So at Katana, we've tackled a lot of those options together in order to do something very, very unique in the market today, specifically around speed. And usually when people talk about speed, it's how fast is my query? How fast can I insert a bunch of data? But here we want to do a little bit more with that definition, right? So speed starts off with, yes, how fast can you get the data in? Yes, how fast can you run PageRank or Louvain or some other complex analysis? How fast can you get a query back? But also the time to insight. So aggregating all of that time saved, in addition to adding in things like an AI pipeline or a machine learning pipeline, putting all that together and getting something very complex out the other side that would have taken people days if you were using incorrect technologies or trying to cobble together complex technologies in order to get this solution, right? One part of that is scale. We talk about scale because a lot of other, I won't say just graph solutions, a lot of other solutions that people use in order to solve these complex problems are stuck on a single machine. That's not bad. Over the last 10, 15 years, we've been able to increase the size of random access memory on a lot of big machines to do very complex things. It costs you a little bit more, but we're able to solve the problems. But with the advent of cloud technology, the advent of distributed computing, starting way farther back than the last 15 years, we've been able to start trying to put the solution together. And there's several research papers that have come out of University of Texas, Austin, which is where Katana Graph started, that have tackled these issues to the specific end goal of having a graph distributed across hundreds of machines. When you do that, you open up this kind of new area. If anybody's familiar with video games, it's like a new area, a new zone you get to explore that allows you to load in hundreds of thousands of gigabytes of data, which is terabytes, I guess, for anybody else, but also billions of edges and nodes. And these, specifically around banks and financial institutions, they usually have that scale of problem, right? I'm dealing with billions of transactions over the course of a year. Before, what people used to do is split that up into smaller sections. I can only do this month's worth of fraudulent actor analysis. I only can do this week's worth of anti-money laundering because it gets so big. What Katana enables people to do, especially in the banking and financial institution, allow them to do this more holistically, larger scale, right? So instead of just focusing on a month, we all know fraudulent actors, they tend to know when they pick up on these trends. So if they're saying, oh, it's only the month, then I'm going to do it on the last day of each month and you'll never be able to catch me, right? So what we've done is we've kind of explored that stretch of time, which is extremely important. On to cloud native. So a lot of these other solutions exist on-prem. I give you a black box, you plug it into your server and it shoots out special sauce on the other side and everybody's happy, right? So that's great, that's fine. That method worked for years. Oracle does that quite a bit. But what about if you're a cloud native company? A lot of these banks right now are getting to be cloud first. With Kubernetes, the advent of Kubernetes being able to spin up clusters very easily and quickly, the on-prem idea of having hardware you have to plug in or unplug if you get an error message, that's kind of going by the way of the dinosaur, right? So we're exploring going to Kubernetes first, exploring GCP and AWS and Azure. What we found is a lot of companies, especially in the banking institutions, they're exploring this cloud first mindset. I think that's extremely exciting. In addition to that, we are a data science first company. We are, which is exciting to me because my past hat was a data scientist, right? So it's, what are you used to? What is the industry's regulations that most people follow, right? So when you go through grad school, usually you have Jupyter notebooks, you have Python, and they'd say, good luck. Here's a shovel, go find some cool stuff in data. But for the longest time, we were dealing with MapReduce. We were dealing with, I have to write the streaming process. I have to write, C-level code in order to do this. And good luck, right? You need to abstract that up to my data scientists, and they get some version of the code itself, and that's not super useful. Here, we've made an effort to make sure that Python and Jupyter notebooks and several other libraries, as we'll go into here in a little bit, they're the forefront of our mind, right? So it is C++ code under the curtains, behind the curtains, but I will say that it does not impact. It's a very little impact from Python to C++, and that's again what people have studied and made sure that is truthful. So as we're going through this presentation, I'm going to try to revert back to each one of these and tell you why this matters. So when we talk about faster and more accurate fraudulent actor analysis, those are two hard things to do because it's usually one or the other. Either you get real-time solutions or you get more complex algorithms that run with a sharper answer at the end. If I run a stream it, I can get like, oh, your probability of being fraudulent is between 75 and 85. Well, that's fine. Some human will go look at that report and decide if somebody actually is fraudulent or not. Or you can go the other way and send it through this huge pipeline. When it comes out the other side, the person might already be retired in the Bahamas or something like that, right? So, you get one or the other, you try to combine them, and usually that doesn't work. And, until now, Katana has now looked at this problem and said, we can solve it. And I'll show you how in a minute. I'll talk a little bit more about the problem first, though. The issue is with this, when we're talking about transactions data, that gives us a small insight of what the actual whole view of a customer is. And when we talk about a holistic view of a customer, we are talking about what PII they have associated with, or personal identification information. What address are they associated with or have been associated with in the past? What loan information they have? Do they have a cosigner for the loan? What accounts do they have? How many closed credit cards do they have? How many external debt collectors are looking for them in different states associated with the Social Security number. The demographic information that comes from where they started, where they're ending, what jobs they've had, things along those lines. Pulling all that data together can be extremely difficult for many, many reasons. One of them being because of the size of the data. So what most banks do is they concentrate on a couple of these, maybe just transaction and some PII, maybe just transactions and account information, loan information, because those are what they're readily accessible to them. But we're able to pull all that information into Katana and get these diverse data sets working for us to find these very interesting bits of information. What does that matter? Well, it matters because you can run things like PageRank and clustering like Louvain. You can run different centrality algorithms like betweenness or weighted degree centrality. You funnel all this information into a feature vector, which you give to your GNNs. They give you something back. This comes to this more precise and accurate model that you're generating. Most GNNs, they don't have this idea of a PageRank or augmentation from a graph. You're stuck with this list of GNNs, which are given to you by a relational database or something along those lines. And you might not have extra stuff that you need in order to get more accurate representation of your data. Who cares? Well, it does matter. We're seeing very, very high results, mostly due to the fact that we can load terabytes of data. We can load billions of edges into a graph. We can get this insight from these different diverse data sets, producing an up to 11% plus increase in PRAUC, which is an industry term. But basically what we're doing is we're allowing people to identify suspicious transactions faster and at scale. And this is going to help us prevent fraud because that time to insight allows somebody to go and cancel a credit card transaction or stop a loan from going out the door. How do we do this? Well, I like this slide because it walks us through it. And it also gives us a chance to look at a little bit of code. So we do have what I consider a revolutionary approach to fraud. And I know that I said I consider it that way. I also did write the slide. So that's why I agree with my own slide. But basically what it allows us to do is start with the graph ingestion, which anybody who's been a data scientist or anybody who's ever had to ingest data into a database or a third-party tool, that's usually the biggest headache of everything, right? It's just, oh, I have a massive data set. Well, I'm gonna hit this button and wait 3 days, it'll be there in a little bit. Well, what this does, it allows us to use things like Dask, distributed Dask, to parallelize this process into Katana itself. Using data frames and distributed Dask allows us to cut down this time to putting data into Katana, which then funnels down to time to insight very quickly. And when I mean very quickly, I mean minutes instead of hours or days. This is massive a speed increase. So again, speed to insight, speed to ingest, but it doesn't stop there, right? Here is what the code looks like. It's actually pretty simple to use. On the right-hand side, you can see what our data frame importer looks like. We're identifying the columns, we're identifying the space, we're identifying the properties associated, the nodes, the edges, and any reverse edges that we might have, which are extremely important when we're talking about certain types of algorithms. So we've seen that we have speed to ingest, speed to run, but also speed to code. And if anybody's ever written a MapReduce job, you know that coding is sometimes the hardest point of your day, and it's extremely frustrating. But when we have templates to help people get to this data frame importer step and get data into Katana faster. Why does that matter? Well, we want to get the data in so we can start doing very complex things with your data, starting with structural feature augmentation. We're using very easy languages. I consider easy languages, low bar of entry. It's not functional programming. It's Python. I can use Python, which is very comfortable for me. I can use, a module that I'm very comfortable with in order to do X, Y, and Z algorithm. I can also use things like OpenCipher. And I mean, obviously I'm a little biased. My background, I did spend some time at Neo4j and learned OpenCipher and Cypher. I think it's extremely intuitive to write. So maybe you're not super Python expert, but to get up to speed with Cypher, OpenCipher is a very low bar. Because all this exists in Jupyter, it allows us to do very complex things in an environment that's very comfortable for us. But we start with this idea of fast ingest, and then we get to this idea of analytical feature encoding, right? So I'm augmenting my current graph, the current representation of my data, which is in graph form, with things like distributed analytics, PageRank, Louvain, centralities, similarities, things along those lines. It's extremely important to run and get those features into our graph so we can have this idea of our graph AI. Give the features that we need in order for graph AI to spit out better, more accurate answers for us. And again, going back to speed, if anybody has had the absolute terrible pleasure of writing something like a centrality algorithm in, I don't know, C++ or MapReduce. I'm going to keep using MapReduce because I banged my head against that for a while. But basically, these are not 3-line things. These are hundreds of lines, and it's extremely hard to not only manage the analytic itself, but how it's addressed on each machine. So especially when we're talking about distributing these analytics, some technologies make you write specific analytics that split up the job across multiple machines so you get an insight back. What we're doing behind the scenes is we're doing all that work for you. So C++ and some of our other special sauce components are allowing us to write a 3-line PageRank. That's I think amazing, absolutely amazing. The fact that it's distributed is even more amazing. But again, this goes back to time to insight and speed. So now that I have all these amazing things in my graph, my feature augmentation, I've got all these analytics, what do I do now? Well, because we've identified several market leaders for us to work with, we've integrated DGL, OpenMPI, and PyTorch for people to use these embeddings to run very complicated training sets and use these graph embeddings to spit out graph neural networks. What does it look like? It's got to be crazy complicated. Well, no, it's actually quite simple. And again, this goes back to what am I looking for in my data? How am I using my data to get some sort of insight and get embeddings out? This is something that I think is extremely useful as somebody who has tried to get into graph neural networks over the course of 10 years. It's extremely complicated. You have to read white papers. You have to figure out what modules to use, etc. But what we're seeing is the actual classification job. This is the training for your graph neural networks. I'm giving it a very easy set of analytical features. I'm saying, give me my split ratio of how much of my graph am I running training on, how much am I testing against. This simple representation allows you to run through a graph neural network extremely fast, especially try different things like different split ratios, see what works for you with your data sets. So after that, we have this idea of how do I use this? So now, great, I have a bunch of feature vectors. My graph neural network looks good. How am I going to consume this? Well, you can spit this out into Parquet files to be ingested, which is industry standard. You spit out to Parquet files to ingest it downline, or to your current pipeline, your AI pipeline. You can spit it back into BigQuery, and then we're constantly adding things to this ability to suck in your graph embeddings, right, and create that more normal process between training and inferring. What does that look like? It must be very complicated. Well, no, this is the code to put into BigQuery. I'm saying exactly what I want. What am I putting in? We're good to go. And there's a lot more slides to these. We have a lot of experts in AI, and feel free to reach out if you have any questions on these. It's non-trivial, obviously, but it does lead to that right-hand component there, the F1 score. As you can see, just using graph features, local features, gives you 1 score. As soon as you start adding in your graph neural network, you see this huge jump in accuracy as far as finding these illicit transactions. And I think that is the key. On top of that, we did say at the beginning, or we didn't, it was on the slide, I just didn't say it. We have this partnership with Intel. And Intel is seeing these insane speedups from using distributed partitions from Katana. So we're not only seeing, okay, just using our graph first approach, we're seeing an extremely large uptake in speed and accuracy. We're also saying, to add on top of that, if you're an Intel shop, you're using Intel processors, you get an even more uptick in your partitioning speed and your training speed. And this is huge for a lot of people, not only in the fraudulent actor world, but in a lot of other different industries as well. And I think that's something that is extremely, extremely useful for a lot of people to speed up their time to insight. That being said, we have a tagline: deep insights, connected knowledge, lightning fast. It says it right there, a little quick blurb. But that'll do it for me.
Cool, man. A lot of really cool stuff there. I mean, the speed differences alone are just kind of mind blowing. Just like
Absolutely.
how, and with how little effort, right? It's like, maybe this is the real magic beans here.
Yes, that's a good point, Jason. I mean, so for me, every programmer I know is extremely lazy. I know I am. So if I can write 3 lines of code instead of 100 or 200, I'm totally down to look at like if this actually it works or
Right,
not.
right. If that gives me, an hour more of video game time every day, then hell yeah. Cool. I'm just actually kind of curious. Like, graph neural networks is kind of fascinating, and so like where do you see this going in the next few years? I mean, obviously there's a whole lot of potential here, right? And so if you're really able to take this amount of data and see like, go from days to minutes of processing, I mean, where do you see that space going?
Oh, I think it's extremely exciting. That's a great question. So in my mind, the idea of transitioning from what we used to have, which is distributed computing, put it all in the cloud, collect all this data, telemetry, everything. We were getting people's steps on watches. It's like we just have this mountain of data to ingest and figure out what to do with. Well, and we had to actually do something with it. We needed to run some insight. A lot of the data, especially for banks and a lot of other different companies like biotech companies, they're seeing this huge amount of data and they're not really able to do anything with it. Well, it's fundamentally usually connected data. So what you need to do is figure out a way to connect the data and gain some insights. So I think because people are starting to realize the speed and the accuracy of some of these models, we're getting away from the older way of thinking where, oh man, this huge architecture is just going to be untenable for my 3 DBAs to run. But hey, if I had something I can connect to in Google and just kind of ship a pipe of data over to it, I can do something really interesting with this. So to answer your question, I think in the next 3 to 5 years, we're going to see just a massive landslide of people adopting more AI and ML features, adopting more of these pipelines as they become easier. Companies like Katana can go and reach out to these very large corporations and say, hey, how can we solve some of your more complex problems? Once they see how easy it is, now how can we incorporate that into your everyday life to lead to some more sharp insights?
Yeah. So what do you think has been like the biggest I mean, if these gains really are legit, which we're saying they are, like, what's been the biggest reason that this hasn't become a thing already, right? Is it, just awareness? Is it difficulty of adoption? I mean, like, what's the reason not everybody's doing this already?
Absolutely, great question. Yeah, so a little bit of that, a little bit of both. It was, probably 3 or 4 or 5 years ago when graph started to become a thing. So it started with things like graph databases, TitanDB, Neo4j, and then obviously now we have ArangoDB and TigerGraph and companies like that. People are willing to adopt it, but then they hit these limitations. So a lot of the people with smaller data, they could run and do what they need to do on smaller databases. They didn't hit these problems. But once that gained adoption and the market started shifting, now the big players want to play and they say, hey, you have a cool toy. Can I play with that too? And they take the toy and they play with it and they realize it doesn't work. It doesn't work for my use case. It can only work for this tiny, smaller use case, right? So we're seeing this huge shift in the mentality of, I know it works. It's been proven by all these other companies, but now I'm on a different level. I have terabytes of data every month, every year I have petabytes of data. How am I going to use the same thing? So what Katana has done is stepped up and said, you can use us. We can solve your problem for you at scale. So that's definitely something I've seen move.
So that's kind of cool. So it also kind of begs the question: is there like, I mean, is there kind of a minimum amount, I guess, or minimum standard of data that is like, hey, below this, if you don't have this much data, it's not really worth it. The benefits aren't there. But hey, once you hit this point, then yeah, you absolutely need to look at something like this. Is there like a cutoff there?
I would say so. In answer to your question, no, I don't think there's a cutoff. I do feel like, well, I'll put on my data science hat instead of my Katana hat for 1 second. I'll just cover the logo. If I can do it for free, I will.
Right.
And that's what most people do, right? We're an open source. Everybody's born in the open source community, right? But when it starts saying like, okay, but I want to put this in my pipeline and I want somebody accountable for SLAs and I want to make sure that this works, then that's kind of the problem, right? So it's not necessarily a scale issue. It's if I'm dealing with real data and if my company has millions of dollars on the line a month based on these pipelines, do you really want to use an open source technology, or do you want to use something like Katana, right? That is built and hardened and tested, and we have people waiting by a phone in case you have something that comes up. Additionally, a lot of these people don't have these several components together, right? So they'll focus on one or the other or another, but putting it together in an intelligence platform, that doesn't exist right now. That's why we're breaking into this new market, right? Is I put the data in, I manipulate it to a graph, I can run my graph analytics on it, then I can do graph neural networks on that without leaving. There's no data ingress or egress. It still sits there in the intelligence platform, and then it leaves and it goes to your pipeline. That's something nobody else is doing.
Okay, which was what I was also gonna or ask you about is like what makes you guys different, right? Like what's your special sauce, you know? But yeah, I think you just kind of answered.
Yeah.
I mean, was there anything else you wanted to add there of like
Yeah.
how are you differentiating yourself in this space?
Absolutely. I mean, so for me, the easiest one is scale and speed, right? So that's the first I usually go to when I speak to people like you or fellow nerds. You know, like they always want to know, okay, well, what makes it special? It's like for me, it's I don't have to say no when somebody says I have a terabyte of data, which I used to have to do, right? So now I'm just saying, all right, give me the data, let's point it to me, and I'll do something cool with it. So that's the easy one. The harder one is being able to talk about the speed to insight. Speed to insight is what we talked about throughout the presentation, right? It's not only the ease of code, it's the ease of use, it's the environment itself that allows people to interact and do some things that they might not be able to do and simplify it for them, especially when we talk about graph neural networks. So the fact that I can write a graph neural network in under 20 lines of code, that's insane. That doesn't usually happen, right? So not only are we talking about scale, we're talking about ease of use, and we're talking about time to insight. So those are the major takeaways that I would give people that are looking at Katana.
Yeah, I mean, what's the downside, right? You know, like, yeah, it's kind of impressive. You mentioned scalability and speed, you know, as kind of the biggest differentiator. You know, can you like expand on that a little bit? Like what are you doing there to kind of make that possible where, you know, like you said, anybody can play, right? It's not like it's just for the small boys or just for the big, huge corporations. Like what are you guys doing there to make that so special?
Absolutely. So the idea of being horizontally scalable. So I might start off with 100 gigs of data, right? And it might only need to be on 2 machines. Well, that's fine. You can run on 2 machines and you still get the positive impact that you have on with your data. You still get the speeds of ingest and speed of analytics. So there's no like minimum bar to show up or it just is terrible performance. So it does allow you to take these more complicated things and get in there and start using the Katana playground. I would say that, at least for me, I very much enjoy the fact that I can sit down and play with a data set, you know, and get it in there, play with it, spin up my instance, and then shut it off. Like that's massive. For a lot of the data science, I guess the data science parts of companies, they like to play. They like to try new things. I want to try something new. I want to try a different data set. I want to do. So the fact that we can say, okay, well, you spin up 2 nodes, you put some data in, you might get, all right, Louvain runs in 25 minutes. You run your algorithms, you get some really crazy, amazing insight. You show your superiors, and they're like, oh man, we need to put this in our pipeline. All right, fine, that was 2 machines. I can now make that same thing run on 20 machines, and it decreases that time. So I can say, oh, okay, Louvain worked with 2 machines. I spun it down. Now every day at 3 o'clock, I run this for 15 minutes or 10 minutes or 5 minutes. It gives me that insight, and then I spin those machines down, I spit out my insight, and I go about my day. So that kind of process, like as far as I can tell, does not exist on a lot of these others. Just why their databases always have to be up. I'm processing a terabyte of data, and the terabyte, when I'm not using it, is just sitting there. And those dollar signs just keep turning. It's
Right?
a lot of data to just sit there if I'm only using it for an hour a day, right? So that's another thing that just I think is great because we're conscious of how a data scientist would use a platform like Katana.
Yeah, no, that's fascinating too, because like you said, you know, a lot of data science people they want to play, right? And they want to get different interpretations. You want to say, okay, how's the result gonna be different if I put it in a different data set, that kind of stuff. And so I think it's interesting that you say like it gives not only better insights but more insights, right? Like you can play with more things. Instead of waiting 3 days to get your results, you could get it in 5 minutes, right? So you can try as many different things as you want and see what you get, right?
100%, 100%. That's exactly what is important when we're toggling through some of the knobs on our algorithms, some of the knobs on our GNNs. If it takes 20 hours to run, I don't really want to go back after that and change something to, one digit up. This is good enough, is what usually people say. It's run for 20 hours. I don't want to do this again. But yeah, if you're doing it in 30 minutes, well, heck, I can get 20 or 30 insights out of this, figure which one's best, and then choose the best model for me. And that's, to me, invaluable.
Yeah, yeah. It also prevents you get the results at 9:30 at night and your boss is asking where they are. It's like, oh, I don't have to answer that email. So.
Yeah, what have you been doing all day?
Right. It's a great question. Playing video games. So one more thing I was kind of curious about is you mentioned AI, right? And that's obviously huge right now, and that's obviously like a big benefit of all this. And that market is only growing exponentially, and people are finding more and more ways to use it. So how is Katana kind of approaching that market? Of all of that, like what's your approach to that?
Well, what we're doing is we're taking feedback from our customers. We've started with the industry standards, things like GNNs. We've started with label propagation and some of the more, I guess, more mainstream supervised and unsupervised methods for machine learning. We've taken those, we boxed them up, we've allowed people to explore them, and we're getting feedback. If this is all they need for a short amount of time, that's fine. But we go to some companies, i.e., like in the biotech space, so people that are doing like, I don't know, specifically they're working with like RDKit or some other technologies. They need integration for that because they want to do things like drug repurposing or genome mapping or things like that. And when they have a lot of data, it's really hard for them to do. So we're exploring constantly on expanding that AI footprint. We have a team of about, I want to say over 30 PhDs that have very, very deep backgrounds in not only distributed programming, they have deep backgrounds in graph programming, AI. Some of our people on our solutions team are experts in biotech, biopharm, and even infosec. So things like cybersecurity and cyber threat. So we're keeping our pulse on what people want. We're making sure we can expand and get those offerings out the door as soon as possible. And we're excited to tackle new challenges in the AI, and we're looking for new, harder problems to solve.
There you go. That's a good way to put it. One more question, if you don't mind, kind of popped up for me. And if this is too complicated to answer or something, obviously, you can follow up with you offline. But obviously, security is a huge issue, right? Like with handling so much data and so many different data sets and all that stuff. If I'm turning my data over to you, right? What are you guys doing to guarantee the security of my data, right? And making sure that like all it and or how does this work with encrypted data, right? Like, I mean, is that even possible? Like, what does that look like?
Very
again,
good question.
A 20-minute answer we can talk about later.
It's not. It's actually a really simple one. I might have breezed over it earlier. So because we're a cloud-first company, we allow whatever company that is using Katana to run their own Kubernetes cluster. So they don't give any data to us. It's just we give them the software. They run it on their Kubernetes system. They can put whatever security they want on it. We're just there to give them the software and give them support. So it's a quick and easy solution, and it's much better than shipping data off to some nerds in Texas, right? So it's
right, yeah. Especially being an Aggie, I can't always trust those University of Texas folks. So it's good to know I don't have to give you any of my data, right?
It makes it a lot easier too from a security perspective side. I mean, I deal with different countries. How do I deal with shipping you data and the laws of PII and how we're going to mask that and what kind of hashing you need to do and obfuscation that needs to happen, and it just becomes a huge headache. It's much easier if we allow people to spin up their own Kubernetes cluster and it's in their infrastructure. They trust the person who spun it up. Here you go. Here's the software.
Cool. Yeah, I appreciate you clarifying that. I wasn't exactly sure how all that worked, so appreciate you clarifying.
No
cool. All right. Well, I mean, Justin, I don't know if there's anything you want to add. I've really enjoyed chatting with you and the fun conversation. And
absolutely.
So,
I had a blast. No, thank you, Jason. I appreciate the opportunity. I appreciate the insightful questions. Thank you very much for allowing me to share my passion for Katana. And yeah, I hope to be talking to you guys more.
Cool. Yeah. So Justin, real quick, I'm sure people will get this, but just so you know, like, what's the best way to get in touch with you or somebody at Katana if they're curious about more information? Um, just through the website, or I mean, is there going to be some
Wonderful.
contact information for you? Or
Wonderful question. Wonderful question. Usually people put that on the last slide. Uh, oops.
usually, but
So
that's okay.
it's very easy. It's Justin at katanagraph.com. So it's my first name, katanagraph.com.
I think we can figure that out. Cool. All right. Well, so we'll go ahead and wrap things up then, unless Justin, I think, it doesn't have anything else he wants to add. So thank you again, Justin, for joining us. It was a lot of fun. Had a great time. Thanks everyone for watching this. Hopefully you got something out of it, learned something really interesting, and maybe find a new way to massively increase your insights and get some better insights into your data. Don't forget, just one more plug, we have a bunch of other great events like this one on our website. So you can find them all at dzone.com/events. We've got all on-demand webinars, we've got upcoming webinars, virtual roundtables, all these different kind of events. So check that out. There's a lot of great stuff, and there's all kinds of topics, just like this one. I mean, you guys know on our website all the different stuff that we cover. So there's topics for everybody, right? Cover a broad range. So I encourage you to check that out. And that's going to do it for us. Thanks again for watching, and we'll catch you guys on our next webinar. Thanks, everyone. Thanks, Justin.
Thanks.